Okay, the first problem I'm going to do is number 26 on your homework. So this is page 455, number 26. This is a PV equals nRT problem. You know that it's using the ideal gas law because you're given a pressure. Well, let's go ahead and write out the things that you're given. Gavin's playing Baba Black Sheep in the back, so you'll get some music in this video. I'm sure you like that. Okay, the first thing we can fill in is R, and R is always the same standard number, 0.821, and then there's a bunch of units after it, but I know all of you are probably not going to put those, so I'm going to leave them out. But in the future, you should always keep them. The problem says 143 kPa, and we need to change that to atmospheres. We need to change it to atmospheres so that it will cancel out with the R constant, and the R is in atmospheres. Okay, when we do 143 divided by 101.3, you get 1.41 atmospheres. Alright, so now we have our pressure. Our volume is given to us in the problem as 1 liter. Our number of moles is given to us as 2.49 moles. And what we're finding in this problem is temperature. So here's our equation again, and what I like to do and what I recommend is isolate your variable that you're solving for before you plug in the numbers. So we're dividing both sides by nr, and so this is what you're essentially plugging in. So T equals, and we'll plug in our pressure, 1.41 atmospheres. Plug in our volume, which is 1.00 liters. Divide that by our number of moles times our R. Once again, usually you need all the units after it, but we'll just make it short. Okay, when you do all that multiplying and dividing, you get 6.90 kelvins. Now the problem actually asks you to have the final answer in Celsius. So this is a little bit weird. We've never done this, but you take 6.90 and to go back to Celsius, you subtract 273. And when you do that, we're going to get a final answer of negative 266.1 degrees Celsius, and that's your final answer.